All right, for sprint number, what are we on now? 4, I think. Sprint4 got some of the collision stuff cleaned up, got tiered collision implemented, and got some code really put in for the AI project that I'm doing. So let's go ahead from top to bottom. First of all, AABB volumes now compute their OBB data correctly. So AABBs and OBBs now collide like they're supposed to. Um, the uh, the okay, for tiered systems, the collidable now has not only its bounding volume that's sent in by the user, whether it's bounding sphere AABB, OABB, but also creates itself a base sphere calculated through the model by default that is used by the collidable group to create and update its group size rough AABB. And that's done by checking the centers of all the various objects that you have, finding the one with the maximum radius, and then computing an AABB based off the min and the max of those numbers. So that AABB is updated every frame uh, through the collision manager. It uses the same command system functionality that the destroyed commands does, only instead of only destroying at the end of the collision manager's life cycle, it updates before the process collision runs through. So that data is used during the collision pair test. So first of all, you get the ABB intersection of the both groups. If that is colliding, then you get the bounding sphere. Yeah, the all the bounding spheres of group one, and test whether any of those collide with the AABB for group 2. If that happens, then you check that specific object that is in groups 2's AABB against each one pairwise, first checking to see if that item of group 2 is colliding with the AABB of group 1. That was Adam's improvement on the system that we discussed in class. So if both of the items are uh, colliding with the other's group AABB, then you check to see if the two specific objects, B spheres, are colliding. If that is the case, then you can do the expensive user-defined test. So I have various visualizer pieces set up here. Yellow group AABBs when there's group collision, orange B spheres when there is this group AABB to that, or this group AABB to that object's B sphere. A burgundy B sphere when there's B sphere collision, and then in the collision, all of the individual bounding volumes will go red when there's a collision actually triggered. So I can go ahead and run that and demonstrate. So as you can see, we've got the group ABB for the ships here. Once I collide with the houses group AABB, it turns yellow because the houses group AABB is, or the houses bounding sphere is colliding with the group AABB of the ships. That bounding sphere is orange. Once I get my bounding sphere into that group AABB, it turns orange. Let's see if I can angle this here. Um, There we go. So now my bounding sphere is colliding with its bounding sphere, but without actual collision, and now we have actual B sphere to OBB collision. So that's the tiered test done. That was the assigned work for this week for the engine. What I've done, if I just close these extra things here, what I've done for the AI project is to finally start putting some actual code into my engine, start laying the foundations for the system that I'm going to build. So sorry, I don't have any diagrams or anything. I'm just going to be describing the basic idea behind the engine side of the system. So the basics of what it's going to be is these goals will each be processed at an individual time. Will keep track of their status, and I can build a tree of those to provide more complex behavior. So each goal is kind of like a state machine in and of itself. It comes in with inactive as the status, is activated, processes through, at some point determines whether it has completed or has failed. When it does that, the the tree will take care of it. You know, the tree will deal with that information correctly and move layers up the tree as soon as the lower down layers have completed, failed, etc. So I've got the goal class created. It's the base level for all the other nodes and various things that will be involved with the tree. So an example of the goal in its most base form. So this would be a leaf goal that is attempting to do a specific task, and when it does, it informs the rest of the tree, is this goal tester that I've written up. So basically what it does is it just counts while it's processing 120 frames. When it hits 120 frames, it's completed. That's all that it does. The more complicated version of a goal would be a node. So a node is, while still technically a goal, a node is designed as a tree structure. So a node has several sub-goals that can be either more nodes themselves or leaf goals at the end of it. Um, the process through of a node, rather than only specifically working on one specific targeted thing, will be to process through the various sub goals that it's been assigned. And when those sub goals complete or when they fail, there can be different results. So, for example, the root node here, is one that uh, is placed at the base of the tree. It will repeat indefinitely in order to keep the tree from completely breaking. Um, and we'll just simply process through each of its sub goals right now in order. Once I get more complicated node processing, I'll be able to do this simultaneously. So I'll be able to send through the update tick to every single node that is underneath the root node. But for right now, I have the sequential node, which processes the first sub-goal in its list until that one fails or succeeds, then removes it from the front of the list, checks to see if there's any more. If there's not, it returns itself out back up the tree. If there are more, it starts working on the next one in line. I still have a lot of work to do to get this actually into a functional state. Primarily, I don't have the game object hook in for this or the manager created yet. Another thing that's going to need to be done is behavior tree as a accessor for the user to have a hook into this system. Another thing that I'm considering is the prototype that I'm basing this on from my AI class had a goal type enum that helped identify the various goals from each other within the system. And while that is a simple and straightforward idea, if I want the user to be able to create their own goals and nodes, which I think is a pretty necessary functionality in an AI system, um, I don't want the user to be able, like, have the access to get into the system and change things like enums. So I'm gonna have to find a way, either a workaround or double check to see if that is a necessary part of this system. So a little bit of progress, still a lot of work to do. And I think that's it for the sprint.